Hi, everyone. My name is Mike Delisle, and my project is the sentiment analysis of quarterly earnings reports to predict subsequent changes in stock prices. So to start, what is sentiment analysis? Sometimes referred to as opinion mining, it is a form of natural language processing technique used to determine the sentiment or the emotion or attitude of a text. It does this by using a lexicon, which literally means dictionary or vocabulary, but in this form, it's used sort of as a scoring system. Some common uses are for social media monitoring and analyzing customer feedback. For instance, if you went to CVS and gave a receipt and you did a survey on it, your survey would most likely go through a sentiment analysis program to determine, is it a good comment? Is it a bad comment? Is there something specific you're complaining about? Some limitations of sentiment analysis are polarity and sarcasm. So when I say polarity, you may think of the extremes, love, hate. Those are actually the easy ones to analyze. Love is obviously good, hate is obviously bad. But the more neutral terms, like okay, I guess, or not so bad, those are the ones that sentiment analysis has a harder time with. And by sarcasm, I mean things like, oh, I love how high the prices are. No one loves high prices, but sentiment analysis might see that word love and think it's good when in actuality your comment is sarcastic and you don't actually like it. So right from the start, we need to just grab the data. I grabbed a list of all the S&P 500 companies, ran it through a random sampling generator to determine which companies I would use in my study. I web scraped their Q3 and Q4 earnings transcripts from fool.com, which is on the left there, and grab their HTML and CSS code. That code was run through a function to grab the P and H2 elements. The P elements were obviously needed in order to retrieve the text, but I also grabbed the H2 elements in order to only grab the section of text that I wanted. As you can see there, well, you can't really see, but there were different contents of the earning calls. There were prepared remarks, questions and answers, and call participants. I only wanted the prepared remarks, so I used those headers to siphon out just that section. That text was then put into a word count function, which you can see on the left as an example. It's this is a data frame for AXP, American Express Q3, I believe, where the first column is the word and the second column is it appears a number of times. Obviously, not all of those words count for anything, like, for instance, the word the. I took the data frame for each quarter for each company and ran it through sentiment analysis 4 times using 4 different lexicons. Those lexicons were AFIN, Bing, Lochran, and NRC. As you can see, they all have different scoring structures, so to speak, as well as dictionaries. When I say dictionaries, I mean, for instance, where are you? The word growth appears in the text 37 times. And you can see it at the top of the AFIN and the NRC data frames, but it's not in the Bing and the Lochran. Now, when I say scoring, I mean how exactly the lexicon scores it. So for instance, AFIN gives a value to each word. That value goes from -4 to 4. Bing simply gives it a positive or a negative tag, and that brings in what I was talking about earlier about those neutral texts. It doesn't even bother trying to do anything neutral. It's just strictly positive or negative. Lochran takes it a step further and adds a few different sentiments like uncertainty and litigious. Then NRC actually takes it 2 steps further. It adds more words, more sentiments, anticipation, trust, joy, and it actually also allows a word to have multiple sentiments. So for instance, momentum, you can see has anticipation and positive. These are some examples of where the sentiment analysis may not work as well as we want it to, especially in business acumen. For instance, the word improve. It may sound like a good word, but what if the person is saying we need to improve, right? That means they're not doing great and they need to improve. Slowly, it's a negative word, but maybe you're increasing sales slowly but surely. And again, I guess you could say it is a negative in terms of the fact that you're not increasing sales exponentially, but it is happening one way or another. So the final list of independent variables were pretty straightforward for the Lochran and the NRC data sets. The indicator variables were pretty much just an aggregation of the different sentiments. A little more work was done for the AFIN and the Bing data. For the total score for the AFIN, that was pretty straightforward. It was just the n column times the value, multiply that out. Total sum is the total score. Total points is how many points were rewarded to a data set, and that includes positive and negative points. So it's actually the absolute value of the value times n, the total sum. And percent positive, that is what percentage of the points were positive points. It may sound redundant, but what I mean by that is two data frames could have the same score of 50, but have completely different positive and negative points. One could have 50 positive points and 0 negative. Another could have 1,000 positive and 950 negative, but they would still look the same in the total score. First thing I did was look at the data using a matrix scatter plot. As you can see from that bottom row, which this is the Bing lexicon, the bottom row is a scatter plot of all of the predictor variables versus price change. And using the eye test, you can see that there's not much correlation. And if you had any doubt in your mind, you can look at that last column where you can see that there's little to no correlation. And then right down the center is the distribution of each variable. As we would assume, the distribution for the price change is normal distribution. Maybe if you were looking at a specific sector, you'd see a left skewed or a right skewed based on if that sector did particularly well or poorly in a quarter. But anyway, I started with multiple linear regression. Right off the bat, I noticed there were major magnitude discrepancies. I actually took the average percent error across the 4 data sets, and it was about 1,200% average percent error. Now, a lot of that was due to JPM. As many of us know, JP Morgan. At Q1, it decreased 1/100%. And my models had it predicting increasing by 2 or 3%. One actually had it predicting to increase by 9%. So if you look at that 9% case, that's a 90,000% error. So that skewed a little bit, but to be fair, even if you took that out of the data set, it still wasn't working great. I tried to use a stepwise regression to determine which variables were the best indicators and only use those in the model. Unfortunately, those results were inconclusive. As you can see, the correlations are all so small and so similar that the stepwise regression pretty much only spit out one variable for each model. I updated those models, still not much better. So instead of trying to gauge the magnitude, what I tried to do instead was determine if you can predict if a stock price will increase or decrease. I continued with the multiple linear regression, but I also added a binomial regression since our outputs are now binary, increase or decrease, and the results were surprising. The AFIN, Bing, and Lochran data sets had a success rate between 40 and 50%, while NRC, the binary, hit 50%, and the MLR actually hit 60%. So I was happy with those results, but as with any model, you can always make it better. So what I did is I made a correlation plot, which is here on the right. We'll just focus on the bottom here. The number is the correlation and how it correlates to price change if you're looking at the bottom row. And how faint it is also how much it correlates. So I used the old eye test and I grabbed all of the points that you could see clearly. There were a few on the cusp. I added those in the model and took them out of the model just to see what would work best. And these equations on the left were the best ones. They're there, I'm not gonna run through, but I took those equations and put them back into the MLR and the binomial regression model. And on the left-hand side, you can see those are the original models using all the variables. The right-hand side, you can see those are the success rates of the updated models. I actually got everyone except for the updated Bing binomial model above 50%. And then I had 2 head and shoulders above the rest, the updated Lochran MLR and the updated NRC MLR, both above 70% accuracy. So my final results, my best models were as I just said, the Loughran MLR model. Those used the variables positive, superfluous, and uncertainty, and gave me a 76% success rate in predicting if the stock price would rise or fall. And the NRC MLR model, which used anticipation, joy, positive, and trust, which gave me a 72% success rate. Some things that I would use to improve this model further is, first and foremost, larger training set and testing set. You'll always gain more meaningful performance measures. And I'd be interested to make sure that the model wasn't overfit for what I was trying to do. I would also select a group of stocks within the same industry, whether that's real estate, healthcare, IT, energy, whatever it may be, and see if stocks within the same sector have a higher correlation with each other, rather than stocks across the S&P 500, which is a broad range. And lastly, and actually what I find most interesting, is I would create many data sets of historical data from a single stock. So I would look at earnings reports from 2021, 2020, maybe even 2019 of a single stock, and see if I can use all of that historical data to produce the Q1 earnings of that stock. Whereas what I did was a bunch of different stocks were in one data set and was used. Thank you.
Any questions? So I maybe misinterpreting this. You said it was 76%. Or what was the best model?
76% success rate. And
you predicted that the stock would rise or fall in price at a 76% accuracy.
correct, yes. So you may be thinking you can make a ton of money off this. Not necessarily the case. You know, some instances the stock might only rise or fall, like JP Morgan, 1/100%, you know. So if you invest $1 million into JPM, you might be walking away with $1,010,000, you know.
Any other questions?
Did you find that the predictions were sort of skewed towards increase in stock price, because the earnings calls, they tend to be more positive, you know, because they might be withholding information in those earnings calls?
Yeah, so that's actually what I expected, and that's what I was kind of nervous about with this project, is that these are CEOs, CFOs, COOs doing the earnings of their business. So they're professionals at making the good look great and the bad looking okay. Surprisingly enough, that actually was not the case. One of my models, I believe it was the Loughran binomial model, returned all negative numbers. So I put it up there, but I still don't see it as a true indicator model. And then on the flip side, when I updated the model, Loughran gave me the Loughran binomial gave me all positive. So yeah, that was a good question. That's exactly what I expected to see as well.
Well, the other thing I was interested in is how did you do the sentiment analysis? Did you Python or R?
So the sentiment analysis was done in R using TidyText. TidyText actually, those are the only 4 lexicons. I shouldn't say only 4. I guess a lexicon's a big thing. But those are all of the lexicons that are available within TidyText package in RStudio.
Any other questions? All right, let's thank Michael and all the speakers.